Predicting the products of chemical reactions, it's kind of challenging for students. But by the end of this video, we'll have you in a place where you can predict the products when you're given just the reactants in a reaction. To do this and be successful, you really do need to be able to identify and classify the types of chemical reactions, and you need to know how to figure out the charges on ions. If you need help with that, there's a link to a playlist where you can brush up on those ideas. So in this video, we're going to look at the three most common type of reactions you'll need to predict the products for: single displacement, double displacement, and combustion. Then we'll cover combination and decomposition in another video. Let's get started with single replacement. So there are a few types of single replacement reactions. For example, you could have iron here as a solid, and then copper 2 sulfate is aqueous. So we have two metals. The iron, that'll replace the copper. So the copper is over here by itself, and the copper, that's going to be a solid. Then the iron is now with the sulfate, FeSO4. And since this is soluble, it's going to be aqueous. So that's the first type of single replacement, and we could predict it because we know the type of reaction. The metal replaces the metal here. Now you try it. Predict the products for zinc solid metal plus copper 2 chloride, which is aqueous. The solid metal, that replaces the copper, and now the copper is a solid, and the zinc goes with the chlorine. But we need to be careful because zinc is always 2 plus, chlorine is always 1 minus. So we're going to need 2 of these chloride ions here for the charge to match. That's why you need to know your ions. We've always got to balance the charge. Up here, the whole sulfate is 2 minus. The iron is going to be 2 plus. So that one's already okay. All right, let's look at another type of single replacement reaction. Sometimes you'll be given the solid metal. That's always a good sign it's going to be a replacement reaction, or might be. And we have HCl, hydrochloric acid, so a metal plus an acid. So here we have our metal by itself. It's always a hint we might have single replacement. And then we have hydrochloric acid. So the zinc, the metal, that pushes the hydrogen out. The hydrogen's by itself. And hydrogen is always going to be H2. You won't have just H, and that's a gas. Now the zinc is with the chlorine, ZnCl, and we know to balance the charge, so it's ZnCl2, and that is the single replacement reaction when we have a metal and an acid. Now you try one. Pause and predict the reactants. The metal pushes the hydrogen out, then we have MgCl, but because Mg is 2 plus and the chloride ion is 1 minus, we're going to need 2 of these. So that's it. And do note in this video, the reactions aren't necessarily balanced. Okay, last of the single replacement reactions. Sometimes you will see an ionic compound, a metal and a nonmetal, and something like chlorine gas. In this case, the Cl2, the Cl replaces the Br, so we get Br over here by itself, but bromine is always going to be Br2, and it's a gas here. You might want to memorize the diatomic gases. Like bromine's always Br2, hydrogen will always be H2, oxygen will always be O2 when it's by itself. So then we have Na and Cl together here. You write the metal first. And that's the last one we're going to look at here. Let's take a look at double displacement reactions now. There are two main types of double displacement reactions. The first, we're going to look at precipitation reactions. So here, the metals, they switch places. So the Pb is with the I, and the K goes with the NO3. In this case, we'll have PbI2 and the KNO3, that's fine. But the problem here is, what states do we have? So we need to know the solubility, and you can look this up on a solubility table. So you can find a video on how to figure out the solubility for compounds in the playlist that I've linked to. It turns out that nitrates are very soluble. So this is going to be aqueous. It's going to stay dissolved. But lead compounds often are insoluble. They don't dissolve. And PbI2, lead 2 iodide, that's a solid. And because it's a solid, it falls to the bottom of the test tube or the beaker. That's our precipitate. So that's a double displacement reaction that's a precipitation reaction. We have a solid that's formed. Now you try one. pause and predict the products here, and then we'll talk about the solubility afterwards. So the metals, they switch places here. We have NaSO4, and since we have a 2- here, and this is 1+, we'll need Na2SO4 and CuOH. And this will be CuOH2. So the charge is balanced. So let's look at the states. Compounds with sodium, very soluble. This is going to be aqueous. Then in general, hydroxides are slightly soluble or insoluble. So that copper-2 hydroxide, that's the solid, and that is our precipitate. So that's how you tell. So that's the precipitation reactions. Let's take a look at another type of double displacement, neutralization reactions. In these acid-base or neutralization reactions, the acid plus the base gives you a salt plus water. And here's why. So the hydrogen and the sodium, they switch places. So we have HOH, and that's just H2O. And we know that's a liquid. Then the Na and the Cl, they go together, NaCl. We put the metal first. And sodium compounds we said are soluble, so that's going to be aqueous. And that's how you predict an acid-base neutralization reaction here. Acids in general begin with H, and bases end in OH as long as they're bonded to a metal. Okay, now pause and you try one. Predict the products for nitric acid and calcium hydroxide. So the H and the Ca are going to switch places. So the H goes with the OH, which we know is H2O, and the Ca goes with the NO3. And because the whole nitrate is -1 and calcium is 2+, we do need 2 of the nitrate ions. And nitrate's very soluble. Put an aqueous after that. So that's our acid-base neutralization reaction. So there is one last type you might see, kind of our classic double displacement reaction here, but we end up with this H2CO3, and that can break down into H2O plus CO2. And that CO2, that's a gas, so that gas would be bubbles. You would see bubbles from this reaction. So just something to be aware of. Sometimes you'll see this, and you might see it written like this. And that's because this H2CO3, this carbonic acid, it decomposed into these products here. Just something to watch out for. Okay, one more type of reaction that we're going to predict the products for, combustion. This is often called organic combustion because we have carbon and hydrogen, but it's really easy to predict. If you have carbon and hydrogen in any form here, you can even have carbon, hydrogen, and oxygen. If you add oxygen to it, you'll always get these products, CO2 plus H2O. So if you see carbon, hydrogen plus oxygen, these are the products. Very easy to predict. That's pretty much it for organic combustion here, with one exception. We do consider carbon plus oxygen giving us carbon dioxide by itself to be combustion as well. It's just there's no hydrogens here, so we can't get the water. So those are the really 3 major types that give students problems, and you see them so frequently on exams. In another video, I'll look at combination and decomposition. But for now, if you know these 3, you're in really good shape. If you need help, the playlist has some practice problems, solubility tables, activity series, and types of reactions to help you further along. This is Dr. B, and thanks for watching.